Imagine a mountain of trees rising above a sun-baked city, with water somehow climbing to terraces far above the river. Ancient writers described such a wonder, but archaeology has never confirmed its exact location or design. So this is not a tour of a surviving monument. It is an engineering investigation. What kind of structure could hold tons of wet soil? How might water have been lifted, distributed, and drained? And why do some scholars believe the strongest clues may point away from Babylon and toward the Assyrian capital of Nineveh? The Hanging Gardens entered history through descriptions written centuries after the period in which they were supposedly built. Those accounts speak of elevated terraces, dense planting, shaded walkways, and a landscape that appeared to rise like a green hillside above the city. Yet no contemporary blueprint survives. Every modern image, including the reconstructions in this video, is therefore an informed hypothesis rather than a photograph of a known design. The gardens were probably not hanging from ropes or chains. The name is better understood as vegetation projecting from raised terraces and walls. To a visitor standing below, tree canopies and vines may have appeared suspended over masonry. That visual effect could be achieved with a sequence of platforms at different heights, each carrying soil and plants, while columns, walls, or vaults transferred the enormous weight down to the foundations. Nebuchadnezzar II transformed Babylon during the 6th century BCE with palaces, temples, defensive walls, and monumental gateways. The city clearly possessed the labor, brickmaking capacity, administrative power, and hydraulic knowledge needed for ambitious construction. That makes a royal garden plausible, but plausibility is not proof. The king left many building inscriptions, and the absence of an unambiguous description of the famous gardens remains one of the mystery's central problems. Excavations at Babylon revealed vast architecture, drainage works, wells, and palace structures, but no discovery has been universally accepted as the Hanging Gardens. Proposed locations do not match every ancient description, and some early identifications have been challenged. The careful conclusion is not that the gardens certainly never existed. It is that the evidence does not allow us to place a single, confident reconstruction on the ground at Babylon. A terrace garden begins with weight. Dry soil is heavy, saturated soil is heavier. Add mature trees, stone or brick paving, water channels, visitors, and the structure itself, and the loads become immense. The builders would need thick supporting walls or vaulted chambers below each planting level. The safest design would spread those loads through many short spans rather than relying on one vast roof carrying an artificial landscape above it. One plausible arrangement uses repeated brick vaults supporting step platforms. Vaults are effective because they redirect vertical weight into compression along curved masonry and down into piers. Mesopotamian builders understood arches, vaults, and massive mud brick construction, although the exact garden structure is unknown. Above the supports, the terraces would require carefully leveled layers strong enough to hold soil while resisting settlement, cracking, and the constant movement of water. Waterproofing would be essential. Irrigation soaking through a terrace could weaken mud brick, rot organic materials, and damage rooms below. Ancient descriptions mention layered construction, but the details are debated. A practical system might combine fired brick, bitumen, compacted material, and drainage channels. The key principle is familiar to modern roof gardens: prevent standing water against the structure, guide excess water away, and protect the load-bearing layer from repeated saturation. The river could supply water, but gravity alone cannot move it uphill. If the highest planting bed stood many meters above the source, the system needed continuous mechanical lifting. The required volume would be substantial in a hot, dry climate. A decorative fountain is one thing. Irrigating deep soil and mature trees every day is another. The garden's most demanding machine may therefore have been hidden inside a tower or service corridor. Several mechanisms have been proposed. A chain carrying buckets could raise water through repeated cycles. A screw-like device is another possibility, especially in arguments connecting the gardens with Assyrian engineering. None of these mechanisms has been proven for Babylon's gardens. What matters mechanically is the same. Many small containers or chambers moving continuously can convert human or animal power into a steady upward flow without lifting one enormous load at once. Once water reached the highest level, gravity became useful again. A header basin could feed narrow channels across the upper terrace. Controlled outlets would direct water toward individual planting beds, while overflow descended to lower levels. This top-down arrangement reduces the number of lifting stages. It also allows one elevated supply to serve several terraces, provided the channels are carefully graded and the flow is regulated to avoid erosion or flooding. A true garden requires more than a thin decorative layer. Trees need enough soil for roots, moisture, nutrients, and stability against wind. Deep beds increase both weight and water demand. Roots can also invade joints and drainage paths. The planting plan would therefore be part of the engineering plan. Large trees over the strongest supports, smaller plants near edges, replaceable soil layers, and access routes for workers to prune, irrigate, and repair the terraces. Even a brilliant design would fail without maintenance. Channels clog with silt, wooden parts wear, ropes stretch, seals leak, soil washes into drains, and plants die when water delivery stops. A royal garden of this scale would require trained operators, gardeners, masons, and a dependable supply system. The wonder was not only a structure. It would have been a daily institution, supported by labor, storage, inspection, and constant repair. Heat and evaporation would shape every decision. Water carried in open channels is lost to the air and to seepage. Shade, covered conduits, night irrigation, and mulched soil could reduce losses. Plant selection would matter as well. A garden designed for spectacle might combine hardy local species with carefully protected imports. The famous green appearance, if it existed, depended on controlling a scarce resource more efficiently than the surrounding landscape. A major alternative theory places the legendary garden at Nineveh, the Assyrian capital, rather than Babylon. Sennacherib described extensive gardens and an enormous canal system that brought water from the hills. Surviving Assyrian reliefs show wooded landscapes associated with irrigation, and the Jerwin Aqueduct demonstrates the scale of that hydraulic program. This does not settle the debate, but it provides a documented engineering context that Babylon currently lacks. A convincing identification would need several kinds of evidence to agree. A datable royal text, a location matching the ancient descriptions, structural remains capable of supporting deep planted terraces, waterproofing and drainage, and a credible route for lifting or delivering water. One isolated well or vaulted room is not enough. The strongest conclusion must connect architecture, inscriptions, landscape, and hydraulics into one system without forcing the evidence to fit the legend. The hanging gardens endure because the uncertainty makes the engineering question more interesting, not less. Whether the famous tradition began in Babylon, Nineveh, or a mixture of memories, ancient Mesopotamian rulers did build monumental landscapes and sophisticated waterworks. The responsible reconstruction is therefore conditional. Terraces could carry soil, layered surfaces could manage water, and mechanical lifting could feed the summit. What we cannot yet say is exactly where this system stood or what form it took. The evidence is incomplete, but the engineering possibilities are real. Subscribe to CuriousClicks for more investigations into how the ancient world may have worked.